Okay, 8 o'clock. All right, so last time we studied graphs, right? We talked about how to formulate the question versus the question, and we talked about collecting data, and then we are doing the representation of the data, right? For analysis. So first graph that we talked about was using pictures. What do we call that? Pictograph. So we talked about pictograph. So you need to be careful when you're using pictograph. You need to show some things on the pictograph. What are the elements you need to include in the pictograph? On top, you need to have the title, right? And you need to have axis, and you need to label them, right? You need to have labels. What is in it? Of course, there are pictures in it, but you need to interpret what the pictures mean. So what do you need? The key. So you need to have multiple elements for a pictograph, right? Okay, and sometimes it can mislead too. So you need to think about the size of the pictures too, right? If it's double of the amount, you need to have the double area of the picture too, and not only the height. All right, so we're gonna move on to dot plots today. So dot plots, I'm gonna show you this small video. This is showing how to do it. It's actually interactive instruction that you can do with your students too. So it's gonna show you how to do step by step how you plot. It says line plot. Sometimes they say line plot, but most of the time we call that dot plot. Even if we don't use the dot, but instead we use X marks, it's still called dot plot. So this is very useful to teach your students too, okay? Because it shows step by step process. Okay, it talked about range and mode, but we didn't learn range or mode yet, right? But some data like this dot plot or any other data can give you the range and mode too. All of the data actually, or all of the graphs can give you the range and mode. So let's briefly talk about range and mode first, okay? What is a range? The biggest number minus the smallest number. There we go. Yeah, the difference between the biggest number in the data and the smallest number in the data, right? So how big the gap is from this minimum to the maximum. We usually say the minimum and maximum. So the most frequently occurred number is, the biggest number is for the maximum and the smallest number is for the minimum. The difference is, what is the mode? The average. The average. It's one of the central tendency, right? So average is sometimes interchangeably used with mean. It's a little different from mode, but mode is also one of those kind of average, right? But sometimes it is same as mean, so we don't want to mix that with mode. Mode is one of those three central tendencies, but it has meaning of right, most frequently occurred number of the data is maybe mode, right? What is the mean? Again, it's an average, right? You find the sum and divide it by the number of the data. What's the last thing in the central tendency? Mean, mode, median. What is a median? The middle number. Yeah, the middle number. So you arrange that from the least to the greatest or the other way around. Okay, so anyways, we have the data here, right? So this is our PE, physical education teacher. teacher made us run around the track for 30 minutes just to see how many laps we could do. And here are the number of laps completed, okay, by the student. So we have the data. How many students are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 students. Okay? And we have the number of laps. Now what do we do? Pretty simple, huh? Okay, so can you tell me about the range here? What is the range in this data? The range? I know you guys know, come on. 5, because the smallest number is 5, largest is 10. The difference is 5. What is the mode? 6, because 6 occurs the most frequently, right? Okay. What could be the mean? You need to calculate that, right? You add them all together and divide it by 14. And that could be the mean. What is the median? Median, you need to find it out what is in the middle number. So starting from here, there, so it looks like between 6 and 7. So median sounds like 6.5. So we're gonna talk about that later. Okay, but this is how you use the dot plot. Okay, sometimes you use the dots instead of the X marks. Sometimes you use the X marks too. So here we have another data. Okay, we have 30 students in Abel's class received the following test scores. So you have 30 different scores there. Some are repeating, right? Because, well, Tana and Jalen can have the same score, right? So it can happen too. I want you to make a dot plot using this data. So what do we start from? Well, you don't have to, the video has shown you to rearrange the numbers from the smallest to the largest. You don't have to, right? You can just put the number above the number line one at a time. Then it's okay. But do not miss any number even if that is repeating. Right? So you need to represent all of these 30 data above the number line. So you're gonna start from drawing a number line. So in your notebook, start drawing number line. And then think about how you can tick marks. So the previous video, we had only 5, 6, 7, 8, 9, 10. So you just need to have 16 marks to represent each of them. But here we have kind of bigger range, right? So maybe if you put all the numbers from 1 to 100, that adds too many tick marks, right? You need to think about it a little bit differently. We can start from the smallest number. Here we see that 52 is the minimum, and maybe the 100 can be the maximum. So you don't have to write all the way from 0 to 50, but you can start from somewhere around 50 or around 52. And then you have all of those marks for each numbers. Now you can mark with X or the dot right above the number. So for example, 82, you can put 82 tick marks here right above 82, right? So please represent all of this in your notebook. How we do that together? So 82 goes above 82. This is 80, so this is 82. I can put 82 there. 97, 95, 96, 97, right above 97. 70, 70, 72, 72, 83, 83, 75, 75, 76, 76, 84, 84, 76, 76, 88, 80, 81, another 81, I'm gonna have two more 81, 52, 82, 82 again, 73, 98, 83, 72, 84, another 84, 76, 85, 86, 78, 97, another 97, 82, 77. Okay. So your graph will look like this, right? So you don't miss any of the data. All of these numbers have to be represented here as X marks on the number line. So we can see the range. Let's talk about the range. What is the range here? The difference between the greatest number and the minimum number. So we can see that is 98, 98 minus minimum 52. We can find it easily using the dot plot. What is the mode? The mode? 82. 82, yeah. And see that that's the highest marks. Okay, so we can see, we can find those information really easily, right? There are some other things that we need to talk about too in this graph. So let's talk about outlier. Outlier is a data point whose value is significantly greater or less than the rest of the values. So here it looks like 52 can be outlier, but we cannot determine that it is an outlier yet. It is a candidate of outlier because we need to calculate whether it is outlier or not. We're going to talk about how to find the outlier later. Okay, so for now we can say that 52 seems like outlier, but we need to test it. It's a candidate of outlier. Okay. So 52 can be or cannot be, but it seems like it can be a good candidate for outlier. Let's talk about cluster. So cluster is a group of points, right? So something like I see cluster here, cluster here, cluster here, and here, things like that. Okay, all the points that are clustered together, a group of points is called a cluster. How about a gap? Gap, we already know what the gap means, right? So there should be large spaces. Like here, there's a big gap between this cluster and that cluster. And I see big gap here too between the candidate outlier and rest of the numbers. Those are called gap. Okay? And the mode, we already talked about that. So the value that appears the most frequently, that is called the mode. Right? Okay. Does anybody have any question for the dot plot? Sandstrom? Do you have any question or comment about dot plot? No? Are we good? Okay, so we're gonna move on. The stem and leaf plot. We're gonna use the same data here. Okay. So we have still ABLE's student scores for the test, right? There are 30 of them. And stem and leaf plot, you need to have a stem and you're gonna have some leaves, okay? So we usually draw a line, okay, vertical line, and the 10th digit becomes the stem. Because we can, well, there are like 100, from 1 to 100 or 1 to 99, there are 99 numbers. Or from 0 to 99, there are 100 numbers. There are a lot of numbers. But if you have only the stem as the 10th digit, you can have 0 to 9. So 10 of them. You can reduce the number of data to show. It's so much easier for us to rearrange it. Okay? So the digit, 10th digit can be your stem, and the 1st digit can be the leaf. So what I mean there is this. We're gonna have a line, and we're gonna put all the 10th digit here, starting from 0 or the other way around, it doesn't matter. No 10th digit, this is 110, 210, 310, 410, 510, 610, 710, 810, 910, and so on and so on. And here you can think about all of those 1st digits that is appearing. For example, if a student had scored 12, you can put 12 there. It shows 12. If the student has scored 57, you can put 57. Another student had 59, then you can put 9 there. So if you see these numbers on the leaf part, they are telling us what the single digits are. And the stem here is showing us what the 10th digits are. Okay? So usually when we have 2 digits, we can show with stem and leaf. This can be applied to 2 digits with decimal number 2. You can put this as stem, and you can put this as leaf. It's very useful to use when you have 2 digits of a number. Okay? For like previous example in the student's number of labs, you cannot do that with the stem and leaf because it has only 1 digit, right? So for that kind of data, it's not appropriate to use stem and leaf. Does it make sense? Okay, so let's use stem and leaf plot using our data here. Okay, so I have explained how you can do that, right? This is something like this. Okay, I will give you guys about a minute to finish this. You can break 82 into 80 and 2, right? You can look at the stem of 8 and put 2 as the leaf. It's just time consuming, I mean, but it's not really hard, right? So eventually you're gonna come to this point. We can interpret all of this. Maybe yours is not arranged in this order. So if you have numbers in the extent in this class. So 50, 60, 70, 89, and shows 82, 97, 70, 72, 83, 75, 76, 84, 76, 88, 80, 81, 81, 52, 82, and so on and so on. Then you're gonna see that, oh, some of the numbers are in order, but some of them are not in order, right? Then you can rearrange that. Using your original, you can twist a little bit by rearranging that as ascending order. So you can change, 7 is still in order. 6. You can change that to 1, 1. One, one, two, two, three, four. Oh, and I forgot 0. You can rearrange that in ascending order. 1, 1, 2, 2, 3. And oh, I have 0. Oh, what's wrong with me today? Sorry, guys. I'm not completing myself here. 0, 1, 1, 2, 2, 3, 4. Using only this data I have so far. You can rearrange that with ascending order. What you need to be careful here is you need to line up the first number in the first column, second number in the second column. Why do we do that? Because then we can see what is the mode easily, right? And how many numbers there are. We can easily compare between, the clusters, between the numbers, 50s, 70s, 80s. We can compare easily when you line that up, okay? So please make sure to do that. And why do we do the ascending order? Because it also gives us the range easily too. Okay. So scalar lip, I don't think it's really hard to represent. What do you think? No. Okay. So we need to just understand what that means. So for example, 97 means it's 97. So if I point out this number here, what does that mean? This number represents 76. So we just need to understand what's going on there. Okay. Okay. So you can have ordered from least to greatest, and smaller numbers at top. So when turned counterclockwise 90 resembles the photograph we use here. Oh, okay. I didn't talk about that. So when you're looking at this one, if you flip it over, what does it look like? It doesn't look like bar graph or histogram, doesn't it? Yeah. So usually when we draw a bar graph or histogram, we draw bars there, right? So we can compare them easily. It's just sideways. Okay, send left is sideways of bar graph or histogram. I'm gonna talk about bar graph and histogram and the difference between those. Okay. In this case, we can say this is more like histogram because we are using the numbers here, right, instead of bar graph. Because bar graph is for categorical data. Categorical data is nominal data. If you guys remember, category is nominal. Right. You can switch the order around with the bar graph and categories, like gender. You can switch them around. It doesn't have to be female, male, or vice versa, right? You can change them around. Then it is categorical. Then you need to use a bar graph with the spaces in between. The numbers like this, it should be histogram because it's numerical data. Okay. I'm going to talk about that as True. So here, order the standard length plot. You're gonna put the number from least to greatest because you can flip it over. Then it looks like bar graph or histogram. Actually, it's a histogram. Okay, standard length plots. Here are some features of the standard length plot. First, standard length plot shows how wide the range of values the data cover, right? So the top number and the smallest of those is the minimum of the data. The bottom right should be the greatest. So for example, if you go back here, you can see the top left, 52 is the minimum. And the maximum should be bottom right, 98 is the maximum. So we can easily find what the minimum and what the maximum is. Okay? And also we can find where values are concentrated. We can see the cluster of the data, right? We can see the cluster of the data. And we can also see whether data have any symmetric image there. If it is symmetric, you can see, it's like almost like down shape or, different shape, it can be symmetric too. Okay? And you can see the gaps. Where are the gaps in data? These things are very similar to dot plot, right? Dot plot has these features as well. You can also see whether any data points are decidedly different from the rest of the data. So let's think about the advantages and disadvantages of the standard length plot. So I already put the advantages and disadvantages here for you guys. Let's consider if this is true. So I put that standard length plot can be created by hand rather easily. Is it easy to do that? Yeah, right? You can just copy it down in your standard length. So it was easy. And it does not become unmanageable when the number of values become large. If you have more than 30 students number, you can still put that in your standard length, right? You can just continuously do that. And the original values are not lost. So for example, if we have 82, we put that as 8 and 2. So the original data value is not lost. However, it loses some information. Why does it lose some information? If you go back here, for example, I put that in order, right? So so 52 does not mean the first student's score is 52. We do not know who has what score, right? So we use a lot of information there. We have all the information that we want to know. But we know a score was obtained, right? However, we do not know which student obtained the score. So something like that, we don't have all the information using standard length. Now we can have two standard length together in one standard length plot. We call that back-to-back standard length. Okay, so when we are comparing two similar scores or two similar situations, I think it is really nice to have a back-to-back standard length. For example, if you are comparing Miss Abel's two classes, let's suppose Miss Abel teaches second period class and fifth period class. So she teaches both same level of students, but one period and the other period can have different score, right? So to compare those two, it is nice to use standard length. So here, second period class, we can interpret this data now, okay? What does this mean? Have 2. That means it's 52. So in the middle, that is the stem. And both sides here and there are the leaves. So we can interpret that 2 as 52, and this 2 is also 52, but that 0 means it's 50. So one student scored 52, and another student scored 50 in second period class. Make sense? So what does this mean? This 9. A student in second period class scored 79, right? And this means 77, 75, 74, 72, etc., etc. We can compare them easily, right? Okay, and we also put the key here. So 0, 5 represents it's 50 because this side, on this side of the standard left plot, right hand side is the stem and left hand side is the leaves. Okay, so we can interpret this 2 as 72. Right, so right hand side is the 10th digit, left hand side is the 1st digit. But on this side, we know that this is stem and that is lip. So it's 52, 62, 64, 71, 72, 75, 77, etc., etc. Make sense? Okay, so tell me about this data. What do you notice when you're comparing second period class and fifth grade class? Which class performs better? Fifth period, why?
The scores are higher.
You can see that, right? So if you see the scores here, I see big numbers are on this side, 80s, 90s, on fifth period. But in second period, I see a lot of students scored in 70s and some in 80s, but just one in 90s. So yeah, we can say that fifth period class performs better than the second grade, especially for this test. Okay, so there are a lot of things that we can talk about. How about the range? What's the range in second period of class? What's the minimum in second period? 50. 50. What's the maximum? 91. So the difference is 91 minus 50 is 1. 41 is the range. How about in the fifth period? What's the minimum? 52. Maximum? 100? No, it's 0. Oh yeah, so it is 100. Very good. The 100 minus 52? 78. So we can find the range. And we also found minimum electron. And we can also find the mode, right? What is the mode in second period class? What number occurs the most frequently? 79. I see 999 here 3 times, right? So 79 is the mode. How about here? We have mode 89. Yeah, it's the mode. So again, when you're comparing one of the central tendency of the mode, we can see mode for second period is 79, whereas fifth grade mode is 89. So we can say fifth grade and fifth period class is doing better. Right? There are a lot of things that we can talk about. Does anybody have a question for back-to-back STEM in this class? Then how about we do that together? So I'm going to give you this data. This is what you're gonna use, okay? I'm gonna give the paper to the students. So nice students, you guys are gonna use that data, okay? You're gonna make back-to-back stem and leaf plots, okay? But here is the condition. We need to make this precedence set age into 2 groups. So you're gonna group the presidents in table 3 into 2 groups. The first consists of George Washington to Rutherford Hayes. Can you mark it off? So all the way from George Washington to Rutherford Hayes. Where is Rutherford Hayes? That's the first group. In another group, the rest of them, starting from James Garfield to Ronald Reagan. Using that, you want to create a back-to-back stem and leaf plots of these two groups, okay, and see if they appears to be different in ages and depth between the two groups. So we're gonna interpret that, finding out which group of presidents seems to have lived longer. So how many presidents are in the first group? 19. Remember, the stem is right in the middle, and the leaves are on both sides. The first group of presidents on the left, and the latter group of presidents on the right. I think that's really a good idea to write them down in order. Yeah. I like Morgan's idea. What she did is she rewrote the numbers in order. So she looked at all the 50s first, and so on the first group, there's only one 50, oh no, 53, 56, 57, for example. Then you put that in order, 53 and 56, and put that in your standard list. If you have a lot of different numbers like 80s, it is better to rewrite them in order and then represent that in the graph. I kind of rearranged the numbers like 50, 50, 53, 56 in the first group, 63, 64, 65, 66, 67, 68, like tongue twisting. And 70, 71, 73, 74, 77, 78, 79, 70s, 80s, 80, 83, 85, and 90, and so on and so on. So I did rearrange all these numbers, the first group and second group of the president's staff. Then I think it's easier to do that. So are you guys done? So does it look like this? So how can we represent this? How can we interpret this? For example, what does this 3 mean here? It means, yeah, one of the early presidents died at 73, right? How about this 4 here? There we go, one of the later presidents who died at 64, right? So it doesn't tell us who died at 64, who died at 73. So we lose some information there. However, all the numbers are represented here, right? So let's compare these two groups of the president's death age. Can you determine which group of presidents seem to live the longer? Which group lived longer? What do you think? Elisa, what do you think? Which one? Later? Why?
More.
So Elisa thinks later presidents lived longer because we had more numbers here in 80s and 90s. 88, 81, 93, 93. So she looked at this part here. Maybe some of you think differently. By looking at the numbers clustered here, so I see most numbers in 70s and 80s, 90s all together. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 presidents died at 70s, 80s, and 90s. So here I have 6, 7, 8. Only 8 presidents died at 70s, 80s, and 90s. So there could be different interpretations for that. So question like this, I don't like it. But you need to show some data why you think that way. Okay? So yeah, I think either one is valid. What do you think? What's your idea? Which group do you think lived the longer? Earlier group or later group? Anna, what do you think?
The earlier group.
The later group?
The earlier
The
group.
earlier group? Why?
I agree with what you said. There's more presidents that lived like 70s to 90s on the earlier side than the later side.
So whichever side you are taking, you need to show with the data, okay? So there is interpretation right there, very good. Okay, the frequency table. Well, we use the frequency table a lot of times, right? So in a frequency table, you want to show how many times data occurs in a range. So we're gonna determine the range first, then you can determine the intervals. But when you're doing the intervals, you need to be consistent. If you are grouping that as gap of 10, then you need to go consistently, right? So when you're making intervals, you need to be careful about the consistency there. And also, the classes should be inclusive. For example, if we are doing heights, then you can do something like 4 to 4.9. Then your next group should be 5 to 5.9, something like that. Okay? So it has to be inclusive. So for age group, for example, if you do 40 to 49, it starts from 40, age 40, up to 49. The next group has to be from 50 to 59. So these numbers are inclusive in that category, in that interval. And also, each item should be fit in only one. So you cannot do 40 to 50 and 50 to 60. You can't, because then where does 50 go? Which group does it go? You cannot put one item into two different intervals, right? So you need to make sure that there is a clean cut there. The classes should be chosen to accommodate all the data, and each item should fit into only one class, one interval. So the data you have here is the frequency table, right? So, well, not exactly. This is just data. Can you put that into an age group like this? Using group to frequency table. It's just frequency table, but we can group them. Okay, so when you're grouping them, you can see what is the smallest number and the biggest number first. So what is the range? What is the minimum here? Who died the longest? James Garfield? Looks like, right? 49. He died at 49. And who lived the longest? Right? Is 93 the oldest? Okay, so what's the difference between 93 and 49? 44? So you have 44 as the range. So let's look at the first one here. How many times that occurs in the range? So we have a range of 44. And how can we make that with a good interval? 40 to 49, 50 to 59, 60 to 69. This is really good interval, right? And it's very consistent. So each group has 10 ages, 10 years, 10 years, 10 years, starting from 40 to 49, 50 to 59, 60 to 69. You can see the consistency there. And all of these numbers are inclusive, so 40 to 49. There's no number, no age that misses anybody, right? And also each item should fit into only one class. So using this, you can use the telemarks. We know how to do the telemarks, right? 1, 2, 3, 4. I mean 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We know how to do that. So for example, George Washington, where does he go? You can put the telling here for George Washington, right? John Adams, 90. We can put John Adams here in the 90 to 99. Thomas Jefferson, 83. So you can put that one telemark here. So once you complete this telemark, you can count the telemarks and put that in the frequency. Okay? So I think it's really easy for you guys to complete. Can you do that? We know that October is 38, because we had 19 in the earlier president and later 19 and 12. Okay. So you guys already know how to do all of this, so it's I don't know, it's not very interesting for you guys, but for younger students, if you guys do real activity using what they are interested or what they like, you know, I think it's gonna be fun activity. So what you're gonna have is this, right? What does it tell us? What can you tell me anything about this graph? This table? What do you notice?
Most died in 60 to 69 range.
Yeah, most deaths occurred between 60 and 69. What else? What else can you tell? It's kind of symmetric, isn't it? From this to that. Yes. A little bit asymmetric, but it's kind of symmetric. Yeah, so you can do a lot of things. Okay, we will pause here and practice here. We'll talk about that on Friday. So this homework is not due yet, right? I will let you know when it is gonna be.